let us talk about the envelope of a parameter family of curves. In this case, we're looking at the one parameter family of curves. Now, you see the word parameter. P-A-R-A. I looked up some information and found that the word para, it's a Greek word meaning alongside or beside, all right, along with. So alongside, just as in the case parallel lines, all right, go in the same direction or opposite direction, but if you consider them are parallel vectors going this way, they run alongside each other, all right. Or paramedics, they work alongside medics, medical personnel, and so on and so forth. Meter is another Greek word meaning measure, so measure alongside, all right. Now, the parameter, it's a certain quantity that has an influence on how a function behaves. It is consistent for a specific situation, but it can be different for a different situation. Let's look at an example. Suppose you say you have a straight line, y is equal to mx plus c, right? Y equals mx plus c. Here, for one specific case, you might have y is equal to 5x plus 2, all right? X and y are the variables. Here, the gradient, the rise over run. Let me redraw that. All right, so it might look more like this. You have a gradient, rise over run, 5 to 1. Very steep line. And this line, it crosses the y-axis at 2. So for this line, 5 is fixed and 2 is also fixed. So you see here that they are specific for this case. So there are two parameters here, 5 and 2. X and y are constantly changing, so they are variables. The variables are x and y. Now the parameter is fixed for this case, but you might have another case where you say y is equal to 3x plus 5. So 3 and 5 are fixed for this particular case. Alright? Now you can also have a one parameter situation. For example, y is equal to mx plus 4. So in one case, y is equal to 1x, so you have x plus 4. Another case, y is equal to 2x plus 4. Another case, y is equal to 3x plus 4. Alright? So 4 is fixed. You are allowed to change m for different situations. So you have a one parameter here, only one parameter. 4 is a constant. X and y are the variables. Alright? So here, that's parameter. The parameter it is used alongside the variables x and y and any constants that are there as well. Alright? Now we're talking about parameter of curves. But here we just mentioned the situation where you have a straight line. Now the straight line in mathematics, it can be considered a curve. It's just that it doesn't change direction, as with what you might traditionally know as curves. Alright? So it's just that we're looking at. Now, you have other situations where you have curves and parameters of curves. Suppose you consider quadratic, a quadratic function y is equal to ax squared plus bx plus c. You have three parameters here, a, b, and c. You could fix c to a certain number and say plus 1. You only have two parameters. You could have a situation where you give b a specific value, say 7. You would only have one parameter, a. Alright? So, if you now say you have negative 2 x squared plus 7x plus 1, there are no parameters, only variables, right? You might have y is equal to x squared minus 3x plus 2, only variables and well, only variables and constants you have here, no parameters. So all of the other numbers are fixed, they are constants. Alright? If you have ax squared, a is a parameter, so you can use different values of a as you want. Alright, so that's the term parameter. Alright? It's a value that you use alongside any constants and variables, and you are free to change that value for a different function, parameter. Now, family of curves. What is this family of curves business about? Family of curves. And remember, I get these information from various sources, mostly online sources. I get some of them from artificial intelligence, right? I'm mostly using ChatGPT. But you have popular ones that I use sometimes. There is the Claude, one of the latest one, DeepSeek. There's Google Gemini, right? So you get these, I get these from various websites and artificial intelligence applications. Alright, now continuing. Family of curves. A family of curves is a set of curves that's generated by a common equation which contain one or more parameters. Right? Now, you have, for example, y is equal to mx plus 2. If you have an x and y axis, you have your x axis and you have your y axis, and then I say y is equal to mx plus 2. M can change. So in the case where m is 0, that's a horizontal line, all of them will pass 2. I have m as some positive value, could be 1, m as negative 1, right? Could be m is equal to 1 point something or negative 1 point something, whatever it is. M could be 2, 3. So in this case, might have M is equal to x plus 2, M equals 2x plus 2, M equals 3x plus 2, M equals 4x plus 2, and so on and so forth. So here, y equal, I'm saying M equal, y is equal to 1x plus 2, y equals 2x plus 2, y equals 3x plus 2, and so on. This is a family of curves. They have something in common. The only thing that changes is a parameter. Alright? It could be two parameters too, but we're looking at one parameter. So that's what we have here. You could have, for example, y is equal to 2x plus c, where c is the parameter. In that case, you have the same gradient throughout, but different c's. Alright? So you could have say 2x plus c. You could have this, you could have this, you could have this. In this case, c might be 2, in this case c might be 4, c might be 7, c might be negative 3, whatever c is. So y is equal to 2x plus 1, y is equal to 2x plus 2, y is equal to 2x plus 3, y is equal to 2x plus negative 3, whatever it is. It's a family of curves, right? Now, you might have a quadratic as well, right? Quadratic equations that generate something like this. It's a family of curves. You might have some quadratic curves looking like this. They have something in common. What they have in common is that they are parabolas, right? Parabolas. So they are a family of curves, right? Now, the next thing we want to look at. Let me just, alright, I'm going to erase, but I'm going to just do one erasing. So let me copy what I have here and just erase and then paste it back. So the next thing I want to look at is envelope. What is that? Alright. So you have different meanings for envelope. But you might know an envelope as some paper container that you put things into, other like letters, right? Or documents that you put inside an envelope. It encloses the letter or those documents, right? Now in mathematics, an envelope refers to a curve that is tangential to each curve in a family of curves, right? So it forms a boundary that envelopes them, right? It forms a boundary that envelopes them or encloses them. that encloses or covers them, however you want to put it. Alright? Now, if you look online, for example, for images of envelopes of a family of curve, you might, I remember seeing something like this before, some quadratic, and then you have the envelope of curve. I probably should have drawn the envelope first. So the envelope is this curve here, right? And the family of curves are these individual curves, where these are quadratic curves. If you want a situation like this on a graph, you can't use one parameter. It will have to be either 2 or 3, right? Parameters of curves. Now, another one that you will find, another image that you will find is something like this. Well, already, let me redo that. Let me draw the lines first. And then you have some circles between the lines. So these two straight lines form the envelope, and these circles are the family of curves. Alright? Now they form the envelope. The straight lines form the envelope. Alright? Now, here, the next thing we want to look at is how to find the envelope. Alright, so these are the definitions. Now that we spend some amount of time and stressing our brain on it, we won't put additional stress right now. So let's take a break, and in the next video we will look at how to find the envelope of a one parameter of curves.